Okay, so today we're going to be looking at factoring trinomials of a greater than 1. And you might think about a greater than 1. Where's a even coming from? We didn't talk about this kind of thing. And so what I mean by that is trinomials, okay, can kind of be written very, generally as ax squared plus bx plus c, right? We have a number a in front of the x squared. We have a number b in front of the x, and we have a number c that doesn't have an x with it, okay? And that kind of makes what we would call a trinomial, okay? What we don't have, though, okay, what we did yesterday is we didn't have an a, right? It was just 1 yesterday, so there was no a there, so it was like we treated it as like a 1x squared, and then we had a b, and we had a c, and we factored it that way. Today we're going to look at when we have problems where a is greater than 1. Okay, so like it could have like 2x squared or 3x squared or something like that, and it kind of makes things a little bit trickier. Okay, so before we get into that though, let's look at let's just kind of refresh our memory a little bit again, just about factoring. So let's remember. So let's I guess look at I don't know. So when it equals 1. Okay, so let's refresh our memory there about factoring when a is equal to 1. Okay, so we'll do one or two of these here. So let's say like x squared plus 9x plus 18. Okay, as an example there. Okay. So again, our goal here is to come up with two numbers, right? We know this is going to equal, bless you, this is going to equal x plus or minus something times x plus or minus something, like this. Okay? And we need two numbers that multiply to make what in this case? 18, but add to make what? 9. Okay? So, we need multiply to 18 to add to make 9. Okay? So, Taylor, can you give me two numbers that multiply to make 18? 9 and 2. 9 and 2. All right, so and this is just like a little side work that I'm doing right here. Okay? So 9 and 2. Taylor, are these the two numbers that we want? 9 times 2 is 18, but remember 9 and 2 also need to add to make 9. Is 9 plus 2 9? No, so that can't be it. Okay? We could also try like negative 9 and negative 2, because 9 times 2, again, doesn't add there. That's right. Haley? Yes! Okay, so 3 and 6 is another alternative, right? And Taylor, by the way, this is the process. Sometimes you guess incorrectly, and so then you keep looking for other things that multiply to make 18. So 3 and 6, they multiply to make 18, and do they add to make 9? Yeah, they do. So then x plus 3 and x plus 6 is what this trinomial factors to be. Okay? There's one other combination of numbers that makes 18. What's the other combination of numbers that makes 18? Yeah, 1 and 18. Don't forget that obvious one, okay? Don't forget the obvious one of 1 and 18, because sometimes that is correct, okay? All right, let's try another one. Just again, to refresh our memories a little bit, make sure we're feeling okay with this stuff. All right, let's try x squared plus 13x minus 30. Okay. X squared plus 13x minus 30. All right. So in this case, Ryan, we need to come up with two numbers that multiply to make what in this case? 30. And in fact, well, careful, not positive 30 though. We had negative 30. We need to multiply to make negative 30, and they should add though to make what? Yeah, 13. So we want to multiply to negative 30, but then add. Yes, if you want to sit right there, no, that's fine. Add to make 13. Okay, sorry, I'm on my word. Space there. Okay. All right. So let's see here. So Ryan, what are two numbers that multiply to make negative 30? 15 and negative 2. That's exactly right. All right. So negative 2, okay. 15 plus negative 2, does that make 13? So that's exactly what we need. X plus 15, x minus 2. Okay. Some of you guys will be able to figure this out or do it, right away without any problems or without having to guess and check. All right. If you don't get it the first time, that's okay. Just keep thinking of other numbers here. All right. I mean, someone else maybe thought, okay, well, we could have tried 3 and negative 10, right? Those multiply to make negative 30, but 3 plus negative 10 is negative 7, not positive 13. Okay. So you got to play around with it here.
Can you move it over?
Oh, yep. Sorry. This way? Oh, this way. Okay. This is about as far as I can move because I don't want to cut off anything else from the other one there. So there's that. All right. So again, that's what we've been talking about so far. All right. So now let me show you, though, another problem. All right. So factoring when a is greater than 1. So now when we change it around on ourselves, so that was factoring when a equals 1, now we're going to look at factoring when a is greater than 1. This makes things a little more complicated. I know you guys don't like complications. Okay, but we're going to... Oh, I'm sorry. This way? All right. I can maybe zoom out. Just like a skosh. That way you can fit more stuff on there. Okay, here we go. So here you can see that our a in this case is 3 in front of the x squared there. All right, and then let me think. So we'll say plus 10x plus 7. Okay. It's still the same concept. So what do we mean by that is that you're still going to need to multiply two things together. It's still going to it will still factor. If it factors, it will factor into two binomials. Okay? But will an x and an x, will x times x give me what I need over here? Yeah, it won't, will it? What do I need one of these things to have?
3.
One of them needs to have a 3. Does it matter which one? No. So I'm going to put it right here. Because we need a 3x squared. If I just have an x and an x, multiplying x times x will only give me x squared, not 3x squared like we need.
Why don't you do x cubed?
Well, because x x to the third power.
Yeah.
Well, because x to the third times x then will give us x to the fourth. We need x squared. So that's why we need to just have an x times an x. But one of them needs to have a 3 in front to make it 3x squared.
Okay, so when you're doing another problem, just like all the problems for a equals 1, it's always 2x's, and now for this one, when you're doing problems, it's always 3x's and then an x.
Well, in this case, because it's 3x squared, we need one of these numbers to have a 3 in front, and the other one to have just the 1. So 3x times x.
So if that 3 was a 5, then
Yes.
5 would go.
5 and 1, right, yeah. If it was a 4, though, you can imagine it would get trickier, because 4, you could do a 2 and an x and a 2x, or you could do a 4x and a 1x. It gets a little bit trickier.
So that's a 3 and an x.
But this one, to get 3, the only way to multiply to make 3, one has to be 3, one has to be 1. So anyway, yep, okay. So, now we look. And again, we can kind of pick and choose here, okay? We need two numbers that multiply, okay, to make 7. But then the tricky part is coming right here, because they're not going to just add to make 10, because we're going to be multiplying one of them by 3. Okay? So we're going to have to hold off on that. We still want to have a sum of 10 though. We still have to add to make 10. So let's think here. Well, what are two numbers that multiply to make 7? Yeah, 1 and 7. So let's go with, we could try plus 1 here and plus 7 here. Okay. Does this one work?
I didn't know
How do we know? Great question. So Julio says, no, it does not work. Julio, how can we tell if we put the 1 here and the 7 here, how can we tell it's not going to work? So 1, yeah, it won't add up to 10. If you look at it here, we'll do 3x times x, that's 3x squared. 1 times x, what's that? 1x. 3x times 7, 21x. So we have 1x plus 21x. That's not going to give us 10.
So can you just like solve it, because like I can't do that in my time.
So yeah, you can multiply it out, absolutely, and then check to see that it's not what you wanted.
So it has to be the same exact equation?
It has to end up being the same exact thing, and if it's not, that means you have to change something around in here. So what can we change then? We put the 1 here and the 7 here. If that wasn't right, what's the only thing we can do to change it?
Negative.
We could try negatives, but again, we don't have any negatives here, so we maybe want to avoid negatives. But again, if I put a 1 here and a 7 here, what's the only way I could change this around to then maybe get 10? Make this one 7, make this one 1. So not that. Okay. So all I did was I kept the 3x and the x the same place, but I just flipped where the 7 and the 1 were going to be. 7 times...
Flip it.
Because, well, this one didn't work, right? You agree with that? That one wouldn't multiply out to give us this?
Yeah, I guess.
Well, okay, so you didn't see that. So 3x times x, 3x squared, so that's good, right?
Yeah.
1 times x is 1x.
Right.
3x times 7, 21x. So it would be 1x plus 21x, which would not give us 10x.
Right.
So that was wrong. It wouldn't work, so we had to stop. We go up here and we say, okay, well, we still need to multiply 7 times 1 to give us 7. So instead of putting the 1 here, the 7 here, let's flip it and put the 7 there and the 1 there. Now let's see what happens. Now I get 3x times x, 3x squared. 3x times 1, 3x. 7 times x, 7x. 3x plus 7x, 10x. That's what we want. Okay? And then 7 times 1, 7. So this is our answer right here. Yes?
So what if, like, instead of moving the numbers around, what if you did 3x minus 1 and then x minus 7?
Okay, we could try that.
Like, well, I know it's really wrong, but like,
Okay.
can you like change it up like that? Or
You could put you could put the minuses in there, that's fine. That would, negative 1 times negative 7 would give you positive 7, but now you're talking about, negative 1x, negative 21x, that'd be negative 22x.
Okay, so those are your only 3 options, though.
Well, you could also do 3x minus 7, x minus 1 that way too. Yeah.
Okay.
Yeah. Okay. So you can see though that gets really complicated, right? Having to worry now about this 3, all right? It makes it a little more complicated. However, let me show you an alternative, all right? So here's an alternative that I'm going to suggest to you guys, all right? What you can do is when your number here is not something other than 1, okay, you take that 3, all right, and you multiply the 3 over here to the 7, all right? So the lead coefficient, bless you, to the last term. Okay. Bless you. So that leaves us with then x squared plus 10x plus 21. Okay, now this is a trick that I'm showing you here to kind of make it easier. Now if you notice, by doing that, I've now gotten rid of the number 3 here in front. It's now just x squared plus 10x plus 21. Okay? And so now we solve it just like what we see. I see x squared plus 10x plus 21, and so we factor it like we normally would factor this. So how would that factor if we normally factor that? Well, it's got to be x times x,
7 and 3.
and it's going to be 7 and 3, right?
Yeah.
So 7 plus 7 plus 3.
And it doesn't matter what order. It could be x with 3.
Right. Okay. Okay. And so that gives us that. Now the problem is, though, that's not the answer that we want, right? Because x plus 7 times x plus 3, that solves this, but we need to solve this. Okay? And so what we're going to do is we're going to then, so this is sometimes called like slide, okay, and divide. And the idea is that we kind of like did the slide right here. This is like the slide, the 3, back to the 7 like that. Okay. And then we also, though, need to divide kind of each of these last numbers here by 3. Okay, we multiplied 3 to the last number. We're going to divide these two last numbers, divide by 3. So yeah, I'll explain that in a second here. Yeah, I know it's kind of weird. Okay, so
I like the other way better.
I understand, but like this is a trick that we can use because, like I said, it lets you turn a problem like this into a problem like this with just like a slight modification. That's all. So yeah, this is easier to solve, I agree. But if you look here, does 7 divide by 3 evenly? No. And so that 3 then comes back out front, and we just put it as 3x plus 7. Okay. Does 3 divide by 3 evenly?
Yeah.
Yeah, what does it become? Just a 1, right? So it's x plus 1. And look at that. That's the same answer.
I like that one.
Then what we were trying to do up here? Yeah, so it's nice. There's less, I guess I want to say like, understanding. It's a trick. It's a trick, okay?
Does it work on every?
So if it factors, it will work on any of those kind of problems. Yes. Okay. So step 4, was to simplify and then move denominators out front.
And you're dividing by your coefficient.
The one that you multiplied, the one that you slid. Mm-hmm. All right. Simplify, move denominators out front. Okay. So let's look at another one of those because that was pretty intense, right? That was pretty tricky. So let's look at some more. Let's look at some more like that. Yes. Yes. You're welcome. All right. Let's try another one here. So let's factor 2x squared plus 11x plus 12. Okay. So, same principle here. We're going to take this 2, okay, and we're going to slide the 2 to multiply back here with the 12. So 2 times that 12 there, and so it becomes x squared plus 11x plus, well, 2 times 12 is 24. Okay. All right. And so now we need to come up so that's the slide part. We slide. Okay. Slide the 2 back to the 12, make it 24. And now we have something with the lead coefficient of 1. So we can just do it like we normally do. So we need to think of two numbers that multiply to make what?
8 and 3.
That multiply to make what? 24. And add to make what? 11. Okay, so 24, that's 8 and 3, exactly right. So this becomes then x plus 3, x plus 8. Okay? And then that was a slide part, and now once we factor it, we now do the divide part. So slide and divide, again, is what we call this kind of like method here. It's like a little trick. It's a trick. It's not the best mathematical understanding, but it helps you get the job done. And what are we going to divide by? It's what we slid by. So we slid by 2, we're going to divide by 2. So we take the 3 divided by 2, take the 8 divided by 2. Okay? Does 3 divide by 2?
No.
Evenly? No. So that 2 then comes back out front. And we get 2x plus 3. Does 8 divide by 2? Yes, it's what? Yeah, so it's x plus 4. And so this thing is equal to these two if you multiply them together.
Is it okay if that my second parentheses is 2x plus 3? That's not
Yeah, that's fine. If you put x plus 4, 2x plus 3, yep. Because again, you can flip around the order of multiplication.
That doesn't give us any 11x.
3 times x, 3x, 2x times 4, 8x.
Oh,
So, right, yeah. Yeah, it makes it easier once you do it like this. Yes, I agree. It makes it a lot easier, doesn't it? Okay? Shall we do another one? Let's try another one here. Okay, let me try another one here. Okay. I'm going to scoot this up some. All right, let's factor 5x squared plus 9x minus 2. Okay, 5x squared plus 9x minus 2. Okay, so we're going to slide here, right? What's the number we slide? 5. Slide the 5. Back to that negative 2. And so this then becomes, we're going to rewrite this as x squared plus 9x minus what? Yeah, 10. So again, we've taken something that didn't have a lead coefficient of 1, we've now transformed it into something that does have a lead coefficient of 1, and now we can factor this like we normally would. So we want to say, okay, this thing is going to equal x, another x there. Two numbers that multiply to make negative 10, but add to make 9.
-1.
So negative 1, positive 10, right? Negative 1 times 10 gives you negative 10. Negative 1 plus 10 is a positive 9. So yep, minus 1 plus 10. So we did the slide part up here. Now we factored, we got to do the divide part. Yeah.
How'd you get -1?
Well, again, it's a matter of kind of like guessing and checking, using a little arithmetic. So negative 1 times 10 does give us the negative 10 that we need. Negative 1 plus 10 does give us the 9. So, sorry? Oh yeah, and now we got to divide. And we're going to divide each of these numbers by what? So yeah, by the 5 that we just slid there. So divide both by 5. Okay. So 1 divided by 5, does that simplify? Not evenly, right? It doesn't divide evenly. So we're going to slide that 5 back out front. So we'll be 5x minus 1. And then what's 10 divided by 5? 2. And it's x plus 2. And this is equal to 5x squared plus 9x minus 2. Okay? That's the idea. Okay. Shall we do one more, and then I'll give you guys your assignment. Okay, let's do one more together. I'll give you guys your assignment. Okay, last one here. And tonight's assignment, by the way, won't have all of these kind of on there. I'll give you some with just the 1 on the front too. Well, actually, we'll see here. I don't know if I have an extras, but we'll see. So, yeah. Okay, so 4x squared plus 4x plus 1. Again, we have a lead coefficient, not 1. So we're going to slide that 4 back to the 1 there. So it becomes x squared plus 4x plus 4. Okay. Derek, what are two numbers that multiply to make positive 4, but add to make positive 4? 2 and 2 is right. Okay. So again, we did the slide part there. Now we factored. We're going to do the divide part. And what will we divide by? 4. Okay, so 2 gets divided by 4, 2 gets divided by 4. Now, does 2 divide by 4 evenly? No, but it does simplify. So we want to simplify that here. So we're going to simplify 2/4. And again, how do you know it simplifies? You can just type in your calculator. 2 divided by 4, math, enter, enter, 1/2. So it simplifies to 1/2. And so 2 here and 4 also simplify to 1/2. Okay? And now we slide the 2 the denominator up front here, the 2 the denominator up front there, and so it becomes 2x plus 1, 2x plus 1. And that's, again, equal to 4x squared plus 4x plus 1.
4x plus 2 and then 4x plus 2 is equal to 2x plus 1 and then 2x plus 1. So
They are if you like divide out. If you divide through by 2, they are equal. But not, you have to like divide by 2.
it would be the same answer.
It actually would not be the same answer. I'll show you. If you multiply these two things out, okay, 4x times 4x is 16x squared. 2 times 4x is 8x. 2 times 4x is another 8x. 2 times 2 is 4. So you're going to end up with 16x squared plus 16x plus 4. You see that they're not.
Yeah,
Then
but
you can
like-
simplify it.
We could factor a 4 out, yes.
I see where she's going with this.
Okay, so you could factor 4 out, but the thing is that 4 is still there. You see what I'm saying? That 4 is still there. This thing is exactly what we need. 4x squared plus 4x plus 1. This thing has a 4 in front of the, so yes, while it's still there, you still have this 4 there. That's not what we want. We want what factors just this. So it's got to be these two.
Yeah, like I get that, but how's that possible? Like how can like a fraction like 40 divided by 60, right?
Yes.
As a fraction.
Yes.
And that's equal to its simplified version.
They are equivalent, yes. Mm-hmm.
Okay, so then how come what we had and
I see what you're saying.
what we got
Are two different things.
They should be the same.
I understand what you're saying. Yes. So, with the way that this trick works, they need to be simplified, and you're right. They won't be. They won't end up being the same thing otherwise. I mean, you're right. In a way, it still kind of like gets you that same answer there. I mean, if you want, you could. You're right. You could just slide the 4 out, and then just put this whole thing over 4 like that, and then that would be correct.
So, like, you could do, like, if you had x plus 3 divided by 6.
Yes.
You would have to simplify.
You should simplify to 1/2.
Okay.
Yes, exactly right. And again, and in the cave, I understand what you're saying. You are absolutely right. But it's part of the trick. The way it works, you need to simplify the fraction, and then, just like when we had 10/5 here, if I had not done 10 divided by 5 and made it 2, if I just put the 5 back out front and made it 5x plus 10, that we didn't have to divide there. We could have just slid the 5 out and made it 5x plus 10. But, we need to actually do the simplifications, simplifying it or whatnot. Okay. All right. Let me get you guys your assignment here. So what I'm going to